So in 8.1, we're gonna talk more about integrals, right? This time, we're gonna talk about them as net change, right? So net change is the accumulation of change over time, right? So whatever is changing, right? If you add up the total change, that's basically what an integral is, all right? Um, the most obvious example is when we talk about distance traveled, from velocity. We talked in chapter 6 a little bit about this, right? And we said that in when we have a graph of velocity, right? Velocity versus time, right? What did we say? We said the area underneath was the distance traveled, right? Um, but really, it wasn't just the distance traveled, because when we took the area under the velocity graph and when we said it's like 75 miles, right? Well, that wasn't just distance. It also had a direction, because when we got positive 75 miles, that meant we were traveling 75 in the positive direction or negative in the negative direction, right? So let's dive right in here, okay? We're gonna start with particle motion. So remember, what we've always said is that if the velocity is positive, it means the particle is moving to the right or in the positive direction. And if the velocity is negative, the particle is moving to the left or in the negative direction. Now, let's build on that. Let's talk about displacement, okay? What is displacement? Remember what we said displacement was? That it was the area under the curve, but it was under the velocity curve, okay? So now let's see how that actually works, right? How is that displacement? What is displacement? Displacement is the difference between where you were and where you are now, right? It's your final minus initial position. So let's see how that comes out of the integral. So displacement is the integral of v of t dt. And when I take the integral of velocity, I get position, which is s of t. And that's evaluated from A to B, which means this is s of B minus s of A, right? And now look at that. What is that? That's final position minus initial position, right? And what is that? That's displacement. So do you see how it falls straight out of the integral, right? Okay, so that's displacement. Well, what's final position? How do you find final position? The final position is the initial position of something, right? So where you started, plus the displacement, right? So if your displacement is -5, it means you're 5 units to the left of where you started. So where you are now, plus the displacement gives you where you are at the very end, right? So this is initial position, right? So let's write it this way. Final position is initial position, right, which is s of A, let's do it that way, plus the integral from A to B v of t dt, okay? So look, initial position plus the displacement is the final position. And finally, total distance traveled. Total distance traveled, now that's just the absolute value of the integral of the velocity. Okay? Questions so far? All right. Okay, so let's move on to this first problem here, right? The function v of t, we're told, is the velocity in meters per second, that's important, of a particle moving along the x-axis. Use analytic methods to find each of the following. All right, so first, determine when the particle is moving to the right, left, and stopped. That is just based on velocity. So for part A, you take velocity and you set it equal to 0, right? What's our velocity? 24 minus 3t. I set that equal to 0. So 3t is 24, t equals 8. That's the point where velocity is 0 or the particle has stopped, right? Now what I need to do is I need to get a sign chart, right? I do a number line that represents my domain from 0 to 10. And on this, I put in the time where the velocity is 0. And so now you want to test points into the velocity. So from 0 to 8, velocity is positive, then it's negative. All right, so when is the particle moving to the right? When the velocity is positive, and that's from 0 to 8. Now, I include 0, but I can't include 8 because it stopped at 8. The particle is moving to the left from 8 to 10, including 10. And the particle has stopped at t equals 8. Okay? Questions? All right. So part B. All right. Displacement. It says find the particle's displacement for the time interval. And then if s of 0 is 3, what is the final position? Right. So displacement, we said, is the integral from 0 to 10 v of t dt. Okay? And that just goes back to the previous chapter. I know you guys know how to find the integral. So displacement is 90. And because my units were meters per second, this is in meters. Okay. Now, what does that mean? If the displacement is 90, that means the particle is now 90 meters to the right of where it was at the beginning. Okay? So particle is 90 meters right of where it started. Okay. Next, I'm asked to find final position. Okay? Well, final position, that means the position at 10. So that's S of 10. And that notation is important. Is equal to S of 0, right, initial position, plus the integral from 0 to 10, 24 minus 3t dt. Let's see what this is. This is initial position plus the displacement, which is how much the position has changed. Okay? So S of 10 is S of 0, that's given to me as 3, plus that integral I just found was 90, so 93 meters. Okay. C, we want the total distance, and that's just the integral from 0 to 10, so that's total distance. That's the integral from 0 to 10 of the absolute value of the velocity. Okay. And you can use your calculator for that one, and you get 102 meters. Okay. Questions? Okay. All right, let's do another one. Again, V is the velocity in meters per second. This time we have a trig function for the velocity. So again, we want when it's moving to the left, right, and stopped. So I take V of t and set it equal to 0. Okay. So 0 is sine of 3t. And now here's the question. The question is, when is sine equal to 0? Sine is equal to 0 when the angle is equal to 0 or when the angle is equal to pi. Okay? So t is 0, t is pi over 3. You want to get all the values where the function is 0 in the interval that you're given from 0 to pi over 2. So now, let's do our number line from 0 to pi over 2. And now look, t equals 0 where the particle has stopped. It's one of the boundaries, which is okay, but pay attention to that. And then pi over 3 is here. Okay. And this function starts off as positive and then negative. All right. Questions? Okay. So now, when is the particle moving to the right? Well, it's 0 to pi over 3. But this time I can't take the 0 because that's where it stopped. And I can't take the pi over 3 either.
Miss Maliki.
Yeah.
Why did you set it 3t equal to pi again? Sorry, I just got confused.
Because we want to know where sine of 3t equal to 0. The way you do it is you say sine is 0 when the angle is equal to 0, pi, 2 pi, 3 pi. Right? Do you remember on the unit circle? Sine is 0 at 0, pi, 2 pi, 3 pi, and so on. So you take the angle and you set it equal to 0 and to pi. And then you solve for t. And then the particle is moving to the left from pi over 3 to pi over 2. And I can include the pi over 2. And it stopped at pi over 3 and 0. So t equals 0 and pi over 3. All right? Okay, so next, displacement. Right, so displacement is the integral from 0 to pi over 2 of the velocity. Okay. So let's see. If you integrate that, this is a u substitution problem, right? But the derivative of u, what's u? 3t. And the derivative is just 3. Remember, and when the derivative of u is a constant, we could just integrate and divide by the constant. So that's what I want to do. The integral of sine is negative cosine. So this is going to be negative 6 cosine 3t over 3. And we're going to go from 0 to pi over 2. And then when you put in the 0, you get that this is 2 meters. Okay. Next, again, S of 0 is 3. What is the final position? Well, S of pi over 2, that's the final position, equals the initial position plus the integral. Okay. So that is 3 plus 2, 5 meters. Questions? Okay, C wants the total distance traveled. That's from 0 to pi over 2, the absolute value of all of this. And that's 6 meters. Okay? So that one, you would either use your calculator, or do you remember how we did it before? Where like you would figure out where the function is 0, and then you make two integrals from 0 to pi over 3. It really doesn't, you know what, I'm not even going to go over it right now. You don't need it right now. It doesn't show up as often, okay, on non-calculator parts. Okay, let's do this next problem. Okay. All right, a car is moving with an initial velocity of 5 miles an hour, which means, right, that translates to v of 0 is 5. Okay, so, and it says it accelerates at a rate of 2.4 t miles per hour. So take a look at this. How fast is the car going when the 8 seconds are up? Okay. All right. So let's think about this for a minute. You want to know how fast the car is going after 8 seconds? That means you want to know the velocity at 8 seconds, right? V of 8. Okay. Now, let's understand this problem. This car is moving with some velocity. Then it started accelerating at 2.4 t miles per hour per second. So it had a velocity, and now it's accelerating, meaning its velocity is changing for 8 seconds. Okay? And now we want to know how much is the accumulation of that change given by the acceleration, right? So that we know how much the velocity is now. Okay. So that means for part A, if we want v of 8, okay, if we want to know the velocity 8 seconds from now, we want to know, first we start with the initial velocity, plus we want to know how much the velocity changed. How much something changed, that's the integral. All right? It's the integral from 0 to 8, because it took 8 seconds, of something. Well, what was responsible for the change in velocity? It was the acceleration, right? The acceleration is what changed the velocity. So if I integrate over the acceleration, I will get the velocity. Okay? Does that really make sense? Let's see if that makes sense. Look, this 2.4 t, it's in miles per hour per second, right? Miles per hour per second. But what's the unit for dt? That's an interval of time, right? Well, dt has the same units as these. This, and this all have the same unit. And if it's from 0 to 8 seconds, then dt has units of seconds. So that means all of that together gives me miles per hour, which is velocity, right? So all that is going to give me a velocity, right? Okay. So let's see. V of 0 was 5 plus, you integrate that, and I know at this point you guys know how to integrate. After all is said and done, we get 76.8 for the integral. So V of 8 is 81.8 miles per hour. All right. Okay, now we need to go on to part B. Part B says, how far did the car travel during those 8 seconds, right? How far did it travel? Well, that sounds like total distance to me, right? And what is total distance? It's the integral of v of t dt, but an absolute value. Okay, so now, are we given explicitly an expression for v of t? Not in this problem. So what the heck do we do now? We find an expression for v of t because we've got a of t. Okay? All right, so look. Do you remember how v prime is acceleration? That means you can go backwards. And the integral of acceleration is v of t. So let me color code this. I need to find an expression for v of t now. Okay? So v of t is the integral of a of t dt. Okay? So v of t is equal to the integral of 2.4 t dt. So this is 2.4 t squared over 2, 1.2 t squared plus c. Oh man, I got a plus c. What the heck? Now what? How can I find the c? Can I find the c? I can find the c. Matthew, don't lose hope. 'Cause look, we've got an initial condition. V of 0 is 5. Okay, so I say the velocity is 5 when t is 0. So c is 5. Oh my word. So then what's v of t now? It's 1.2 t squared plus 5. Okay? Yeah, okay, but we're not done yet. Because what was the problem asking us? How far did the car travel? So we want the total distance now, right? Total distance, right, is the integral of the absolute value of 1.2 t squared plus 5 dt from 0 to 8. Okay? Okay, so now you plug this into your calculator and you get that this is 244. But I got another problem. Because look, this is still in seconds while this is miles per hour. So the 244, you have to divide by 3,600 in order to fix for the units. So that gives you 0.068 miles. Okay, here, and example 4 and 5 are related. It says the figure and the equation below gives the velocity of a particle moving along a horizontal s-axis from 0 to 5. Describe the motion of the particle. Again, you want to know where it's going to the right, left, and stopped. So again, you need when the velocity is equal to 0. Well, if this is the graph of the velocity, then this is where it's 0. So basically, you want v of t, which is t squared minus 8 over this, to be equal to 0. So what you want to do is use your calc to graph and to find the zeros. It just so happens that this is at t equals 1.254. All right, this is where the velocity is 0. So now I can say the particle is moving to the left from when the velocity is negative, right? So from 0 to 1.254, it's moving to the right after that until 5. And then it stopped at t equals 1.254. Okay. All right. So basically, what have we learned today? What we've learned is this. If I take the integral of a of t dt, okay, that gives me v of t plus c, okay? And then if I take the integral of v of t dt, that gives me s of t plus c, okay? Commit those to memory. Memorize them. And now that we've laid that out, let's do number 5. Suppose the initial position of a particle is, of this particle in example 4, the initial position is s of 0 equals 9. And you want the particle's position at t equals 1 second and 5 seconds. So basically what you want is s of 1 and s of 5. Okay? And we're always going to go with this. The new position is the initial position plus the displacement. And what's the displacement? It's the integral. Okay, so here we go. S of 1. Where is it at t equals 1? Well, where did it start? At s of 0 plus. How did the position change? Well, the integral tells me how the position changed. I'm going to integrate this function. So it's going to be t squared minus 8. And then I'm going to move it up and write it like this to make it easier to integrate. Okay? So this is s of 0 plus t cubed over 3. And then here, I add 1, so it'll be to the power of negative 1. So plus 8 over t plus 1 from 0 to 1. Okay, what's s of 0? 9 plus. Plug in the 1. You get 1/3 plus 4 minus plug in the 0, you get 8. So altogether, 16 over 3. And then for s of 5, we do the same thing. It's s of 0 plus. How much did the position change? Well, it's the integral from 0 to 5 of v of t dt. Well, let me just put in the v of t. It's the same function. So this is s of 0 plus the same function. This time I go from 0 to 5. So I get 9 plus 5 cubed over 3 plus 8 over 6 minus 8. And that is 44. Okay? So that's where I'll stop today.